Okay, the next thing we're going to run through is we're just going to run through our basic rules of exponents. Okay, and I'm going to do so by kind of doing more of an investigation, showing you guys why the rules are the way that they are. Okay, so our first example here, I have 3 to the 4th times 3 cubed. Okay, so for this problem here, if I have 3 to the 4th times 3 cubed, what we're going to do is we're going to write this in an expanded notation. So if I have 3 to the 4th, that's really a 3 times 3 times 3, right? There'd be 4 of those 3's. Times a 3 cubed. So a 3 cubed would be 3 times 3 times 3. There are 3 3's in that case there. Well, that would equal 3 to the 1, 2, 3, 4, 5, 6, 7. That equals 3 to the 7th power. And it's easy to see when you expand that out. So what is my relationship? How did I get 7? What's something easier I can remember? Well, I have 4, so if I use the wrong color, I have a 4, and I have a 3, and what is 4 plus 3? Or 4 plus 3 gives me my 7. Okay, so this is the multiplication rule of exponents. And the multiplication rule of exponents say that if you have the same base, they have to have the same base, then you can add the exponents together. So if they have the same base, a to the m times a to the n would become a to the m plus n. And that's our multiplication rule for exponents. Next one we have is called our power rule for exponents. So I have a 2 squared cubed. Okay? So the first thing that I have here is this 2 squared needs to be cubed. Okay? So really 2 squared cubed is 2 squared times 2 squared times 2 squared, right? It'd be 3 times. Okay? Now, I'm not done expanding yet, because then I could expand 2 squared. And whoops, that wasn't in parentheses on the last one there. 2 squared is really 2 times 2, 2 times 2, 2 times 2. So when I'm trying to simplify this, how many 2's do I have up there? Well, that would be a 2 to the 1, 2, 3, 4, 5, 6 power. 2 to the 6th power. Okay? So I had a 2 and I had a 3. So how did my 2 and my 3 get me to my 6? Well, 2 times 3 equals 6. Okay? So this is called our power rule. And our power rule says that if you have an a to the m to the n power, that you are going to multiply those two values together. So if you guys see a 2 squared cubed, you could simply take 2 times 3 to give me 6, and then you know that that is the same thing as 2 to the 6th power. Okay, and that is our power rule that we have. Next one we have still deals with our power rule, but this time if you guys notice, you've got 2 different variables in there. So I've got an xy cubed. So an xy cubed would be an xy times an xy times an xy. Okay? And all of those things are being multiplied together, right? So I could look and I'd say, well, that's an x to the 3rd power. And then that's a y to the 3rd power. So basically what this is showing us is that 3 goes to the x and that 3 goes to the y. And we know for a fact that they multiply those numbers, right? So that's taking a 3 times what? Well, if x doesn't have an exponent, that's an x to the 1st power. Y doesn't have an exponent, that's a y to the 1st power. So we would take 3 times 1 to give you my x cubed, and I would take 3 times 1 to give you my y cubed. Okay? So this doesn't really have like a fancy name like the power rule. This is just saying that this exponent on the outside has to distribute to both of those values on the inside. So ab to the n power becomes a to the n and a b to the n power. So you need to make sure that goes to everything in the parentheses. Next one we have, this is going to be our quotient rule of exponents. And I'm going to show you guys the quotient rule, but then I'm going to explain to you guys that I really don't do the quotient rule. Okay, so let me show it to you first. So we're going to expand it out. X to the fifth power, x to the fifth power would be 5x's on top, right? And then it would be 3x's, x cubed is on the bottom. Okay, now when you guys started working with fractions, you guys learned that you can kind of cross some things out, right? So these x's would cancel, these x's would cancel, and these x's would cancel. So when I do that, I'm left with an x squared. So if I have a 5 and a 3, how do I get to a 2? Well, hopefully, you guys can look at this and say, oh, well, you would need to subtract. Okay, so the quotient rule says, again, the quotient rule says if they have the same base, that's a P. If they have the same base, then you can subtract their exponents. Okay? Now, I personally do not like this rule, and the reason that I don't is a lot of kids get confused because negatives will show up if you use the quotient rule. And for example, let's say that I had an x squared over an x to the sixth. Okay? Well, you guys would do the quotient rule, and you'd go x equals 2 minus 6. That gives me x to the negative 4. Oh, no, that can't be right. I must have messed it up. It should have been 6 minus 2 to give me 4. And that's wrong. You had it right the first time. You had it right the first time. And that's why I don't like it. Because I don't like it. You got negatives, and then you got to remember what to do with the negatives. I think it's way easier if you just look at this fraction like this and you say, okay, I've got an x squared on top, and I've got an x to the 6 on the bottom. Well, x squared is really 2x's, so I'm going to cancel 2x's there. And then I need to take away 2x's from the 6, which leaves me with a 4. So what do I have left on top? Well, I have nothing, but you always have a 1 left over on top. And then on the bottom, I have an x to the 4th. So I just cancel, kind of like what I do up there, but I just don't expand it all the way out. I prefer to cancel rather than using the quotient rule. I do think that's easier. Okay? Along with that quotient rule, I did want to show you guys this one down here, and this is going to be very similar to that other distributive property one. So if I have an x over y squared to the 4th power, that is going to give me an x over y squared times an x over y squared times an x over y squared times an x over y squared. So if I'm trying to figure out what that is, well, on top, I'd have 4 x's, right? So this would be an x to the 4th on top. Now on the bottom, we haven't really done one like this. Well, y squared is really y, 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 y. So how many y's do I really have? I'd have a y to the 8th power. Okay? So if I have an x over y squared to the 4th power, that's the same thing as an x to the 4th over a y to the 8th. So what you guys hopefully will see is that 4, just like on this slide back here, where that n distributed, the same thing will happen on this slide here. That 4 is going to go to the x, and it's still a power to a power rule. So 4 times 1 gives me my 4. That 4 is going to the 2. 4 times 2 gives me my 8. Okay, so basically what we're saying is that if you have an a over b to the n power, that n goes to the top of the fraction as well as the bottom of the fraction. That becomes an an over a bn. Okay? And that is our distributive property for a fraction. There's really not a fancy name for that one either. Okay? One more thing that I want to show you guys, and this is also just kind of a caution one. Okay? Your exponents. Okay? Remember, PEMDAS. Exponents come before multiplication. Okay? So what I have up here is I have an a times a b to the negative 2 power. Okay? So the first thing that I need to do is I've got to deal with my exponent. And in this situation, that negative 2 is only with my b. It is not with my a. Remember that negative exponents cause things to move to the bottom of the fraction, right? So for this situation here, a times b to the negative 2 power, or ab to the negative 2 power, your a is staying on top because that a has an exponent of a 1. A's exponent is positive. However, my b is going to have to move down to the bottom, and that will become a b squared. So ab to the negative 2 is going to be an a over b squared. That negative exponent only applies to the one that it is closest to. Versus if the exponent is on the outside of the parentheses. First off, we should remember if it's on the outside of the parentheses that we've got to distribute that 2 into everything. The 2 goes to the a and to the b. This is really an a to the negative 2, b to the negative 2. Remember, when you have parentheses, it has to distribute in. Okay? So in this situation, a to the negative 2 needs to move down, and my b to the negative 2 needs to move down. So what do I have left on top? Well, I have nothing. We always have a 1. So that's a squared, b squared. Okay? So again, notice the difference between this one and this one here. Exponent only goes with the b, so that's the only thing that moves down. Exponent has to distribute in, so they're both down on the bottom.